Hello everyone, welcome to day 23 of Leetcode Mein challenge. Today we have question number 474, ones and zeros. In this question, they have given us an array of binary string and two integers m and n, and we have to return the size of the largest subset of strings such that there are at most m zeros and n ones in the subset. A set x is a subset of set y if all the element of x are also the element of y. In example 1, they have given us this string which contain all these digits, that is 1 0 0 1 1 1 0 1 1 0, and we need at most 5 zeros and at most 3 ones, and we have to return the largest subset of string, size of the largest subset of the string including this. So if we need 5 zeros and 3 ones, which all things we can take? We can consider this as it has 1 0 and 1 1. So now we are left with where we need 4 zeros and 2 ones. So we can take this string. According to this, our zero count will be like we have 4 zeros now and we have 2 ones. So we are left with 1 0 and 1 1. So we can consider these two strings, and these are the largest string possible. So the length of these are the largest subset possible. So the length of this subset is 4. That is what we can return. The other values we can add is using this 000 and 1, where we are left with, we need 2 more zeros and 2 more ones, and we can then include the 1. Then we have 2 ones and 3 zeros, but we don't need exact 5 zeros or exact 3 ones. At most less than it also can work, but the size of the subset should be larger. But in this case it's not larger when we are taking the 001 and 1 case. Similarly, when we are taking this case, it is not larger, so the larger we have to return, that is the 4. The invalid case is 111 In this we got 2 zeros, which is okay because at most we need 5 zeros. So less than those is acceptable. But we have 4 1 in it, but we need at most 3 ones. So this is not acceptable. That's why this is the invalid case, and that we have to exclude it. So basically this problem is somewhat like the knapsack problem, where we have to include where we have to decide which index to include and which to exclude. So similarly we will do this. So for now we have the value of m is 5 and n is 3. Like if we decided to take, first thing is like we have this value 10, and we are thinking like whether to include it in our subset or whether to exclude it in our subset. If we are saying yes, that means we are included it in a subset. No means we are not including it in a subset. So if we are including 10 in a subset, so okay, this will have the make sure the count of zeros, and n will make sure the count of ones. At most we need 5 and 3, and if these values are going into negative, we have to exclude that case. So for 1 and 0, we have the count of 1 is 1 and 0 is 1. So in this case our m will become 4 if we are accepting it, and our n will become 2. And if we are not accepting it, then similarly our m will remain same, 5, and our n will be 3. Now we have the other value, that is 0 001. Over this side also we have this value 001. Now again we have choice whether we want to include this, whether we don't want to include this. This is yes case, this is no case, this is yes case, this is no case. So if we are saying yes to it, that means we have 3 zeros. So we are left with only 4 zeros and minus 3. Then our m value will become 1, and our n value, as we have only one in this, and here we have 2. So 2 minus 1 is 1. So we are left with this. And if we are saying no, then we will have the same. Our m value will be 4 and our n value will be 2. In this case, if we are saying yes, then our m value will become 2. Why? Because this is 5 and this is 3 zeros, so 5 minus 3 is 2, and our n value will be single one, so 3 minus 1 is 2. If we are saying no, then similarly our m value will be 5, it will not change, and our n value will be 3. Now the other things which come is triple 1, 0 0 1. Over here also we have triple 1, double 0 1. Now if we similarly we will have triple 1, double 0 1 for this level also, but now I'm fully solving this side. So when we just want to include it, that is saying yes to this value. When we don't want to include it, saying no to this value. When we are including it, our m will become, it is already 1, m is for 0 count and this is 2, so 1 minus 2 is minus 1, so our m value will go in negative, that is minus 1, and our n value will be 1, and we have 4 ones, so 1 minus 4 is 3, so n value will be negative 3. And if we are not including it, that means we are saying no, so our m will become 1 and our n will also remains 1. So this case we will exclude, because here the value of m and n are negative, that we don't want. If we further iterate it, we have the option of going with a single, that is 1, and we have again the option saying yes to it, that means adding it to the subset, and saying no to it, that is excluding it from the subset. So when we are saying yes to it, so this is 1, so our m value will remain as 1, but our n will now be 0, because n have the 1 count and this is 1. And if we are saying no, our m will be remains 1 and our n also remains 1. Now again, for the value 0 on another level, we have two options: going with it, adding in it in the subset, and saying no to it, not adding it in the subset. This time when we add it in the subset, our m becomes 0 and our n also becomes 0. When we are not adding it, our m become 1 and our n become 0. So now we have to return the largest subset. If we consider this one, this is like if we are considering this one where m and n value become 0, in this subset if we are going, I will write this over here what we have included. We have said yes to 1 0, so that means 1 0 is including in our set. Then we have said yes to triple, we are coming from here, then we came to here, then we have included triple 0 1 also in our set. Then we are moving, we are then we are saying no to this, then we are going over here, so we are saying no to this triple 1 0 1, and then we are saying yes to, 1, so we are including this, and then we are saying yes to 0, and we are coming here. We can go in backward direction also, but I am showing you from the upward. So this is 0, this is one set. The other set using this we will get is, we are saying yes to 1 0, we are saying yes to triple 0 1, and then we are saying yes to 1, but we are saying no to 0. Here we are saying no to 0. See, we can consider this case, because if both of these value become 0, it's well and good, but we have to return the at most, like it should at most be 5 and 3. It should at most be 5 and 3. If the value is less than also 5 and 3, it is well and good. And we have to return the maximum length of the subset. In this, the maximum length is 4 of the subset. In this, maximum length is 3. We will get many cases when we will go down this tree also. When we'll iterate this, we'll get more, but out of them, if we will see, we have to return the maximum answer, so we will return 4 as the answer, and this is the subset we are going to get. This is our approach of doing it. So now let's code it up. How to do this? First thing is, what is coming to my mind is, we need a frequency array which store the count of 0 and 1. So for that, I need new integer whose columns should, for each of this string, like one by one. For this we need how many, we need the count for zeros and 1. For this particular string we need the count of 0 and 1. For this particular string we need count of 0 and 1. So this rows will be equals to string dot length, and its column will be 2, which store the count of 1 and 0. And what we will do it, we will iterate through string. We will go through strings, and what we will do, we will have integer frequency of I, and we will have some function which will give us frequency of 0 and 1. Which will give us frequency of 0 and 1, and then we will increase the value of I. This we will get the frequency map, and from here we will write some method that will solve and give us the length of the largest subset possible. So we will write some method, and inside this we will pass something, like we will pass first our strings, we will pass our m and n, we will pass the index, and more importantly we will pass this frequency. So this is frequency we will pass. Now first thing is we will write the code where we will have the 0 and 1 to count the 0 and 1 frequency. So what we will do it, it is private. We need a 1D array which have the frequency the frequency, and we will pass string in it. And what we will do is we will have the 1D array which will of the length 2, and what we will do is we will have the for loop for character ch in str2 character array. If our character is equals to 0, then frequency of 1 plus plus, this is like 0 plus plus, else we will have, if this is 1, then frequency of 1 plus plus, and at the end we will return the what, we will return this frequency array. And this is how this frequency method is done. And now we have to write the solve method, that so private integer solve, and it will take the input as the string m and the index, and the other thing is the frequency array where we have the frequency stored for the 0 and 1 for every particular string. So if our index which we passed is greater than the string dot length, or our m plus n goes negative, then we simply have to return 0. Otherwise what we have to do, exclude and include case, whether we are including this particular string for a subset or whether we are excluding this particular string for a subset. So we will create exclude and the other integer variable as include, whether we are including this or whether we are excluding this. The other thing is, now we will take out the 0 frequency that we have stored in frequency array. So we will tell for this index we needed 0 frequency, and similarly we will create a variable for 1 frequency, and then we will go with the like in the frequency array, and we will ask we need the 1 frequency. When it will give us 1 and 0 frequency, we will check if our m is greater than equals to the 0 frequency, because m has the count 0, and our n is greater than equals to 1 frequency, then we can include it. So we can include it. So we will add 1 plus, we will call our solve function again, and this time we will pass, the string will be same, but as we have included it, so our 0 will be decreased, so our 0 frequency will be decreased. Similarly, if it has 1, then our 1 frequency would have also decreased, and every time if we are going, we will increase the index and we will pass the frequency. This is the case when we are including that particular string in the subset. This is like when we are including the string in our subset. This is when we are including the string in our subset, and when we are excluding, excluding this string, then what we have to do, we simply have to call the solve function. We will pass our string m and n, there will be no changes because we have excluded it, but our index will always increase, and we will give the frequency array. What we will do over here, we will have the include, which will have the maximum of the include and exclude, whichever is the maximum, which will have this, and we will return this. Or we can directly say that we can return the maximum of include and exclude. Okay, arey yaar, this space, let's run this. Okay, frequency, okay, line 7, frequency of I is this. What is going wrong in it? Frequency of I, frequency of I, yeah, this is frequency, this na, frequency of, what is wrong, cannot find the symbol frequency, it is over here na. What is the issue? And we are passing str all set, str is this, and frequency we have made over here, it will give us, okay, this is wrong, brackets we have used. Let's run this, it's working, let's submit it. Okay, it will give us TLE. Why? Because we are calculating again and again for the include and exclude. Like it will be stored somewhere na, if what will be the frequency, what will be the include if we include this particular string, what will be thing if we will exclude this particular string. Like for here we are using this 0001 again and again, and then we are doing it. So if we store this particular value somewhere else, then we will know, like after including it what will be our m and n, after excluding it what will be our m and n. So to do this, to optimize this, what we will create a 3D DP, initialize it with null, and over here okay, for over here we will initialize it, new integer, it will contain m plus 1, n plus 1, and here we will have string dot length. We'll just memoize it, and nothing we will do, we will just simply whatever we are getting it over here, we will check if dp of m n and the index is already, if this is already present, we will just simply return it. We don't need to calculate it again and again. Recalculation is not required. This will save our memory. So yeah, if this is already done, no need to do it again and again. And we will store it also, like from where we are getting it. So over here, after the exclude, what we will do is, in this we will store this. We will store this and we will return directly this. Sorry, we will return directly the dp which we are getting over here. And let's run it. This is our optimized approach, so that we don't need to do the same function. Okay, cannot be converted to boolean. Wait, what? Okay, this should be, if this value is greater than 0, that means this thing we have already calculated. Then we will simply return this is working. Let's submit it.